All right, it's 40 minutes past the hour, so I think we're live. Good morning, everybody. My name is Benjamin Pierce. I have the pleasure and honor of hosting this first session of Ask Me Anything. In the Ask Me Anything sessions, which are going to be ongoing throughout PLDI, we're going to have 15 special guests. Our first one this morning is Simon Peyton Jones. So this will be going on, though, all through the conference, today, tomorrow, and Friday. There is a Slack channel that you can use for asking questions. It's called PLDI Ask Me Anything. And you'll see that there's one thread per guest, and you should use that thread for asking questions. People have already started asking questions. There's a whole bunch of interesting material queued up. And of course, you can continue asking questions during the session. The main part of the session will be about 20 minutes, will be exactly 20 minutes. But the next Ask Me Anything speaker is not for another hour after that 20 minutes ends. So, so we can go over if people want. And if we go really, really over, we'll switch the session to some other venue. Okay, now about Simon. Simon has been a hero of mine forever. He has been a major figure in the functional programming community. He's been enthusiastic about functional programming since about mid-80s. He is, of course, one of the originators and main implementers of Haskell. He is also recently the chair of the UK Computing at School community, and most recently of the UK National Centre for Computing Education. So people may have some questions about those. And he says that his proudest accomplishment is becoming a Fellow of the Royal Society, along with Isaac Newton, among others. With no further ado, let's go straight to Simon. So Simon, welcome. Good morning.
Oh, thank you. Oh, I have another proud accomplishment. I've turned 60 and I still have nobody reporting to me.
Nice. Well done. All right, shall we have the first question? The first question, I apologize for pronunciation of names all the way through. The first question is from Jaron Katema from ESI in the Netherlands. And it is quite open-ended. How do you see the future of functional programming? For a while, a lot of us thought functional programming languages were the future. However, although there are some areas where functional programming has taken hold, the current trend seems to be the introduction of functional programming features and programming styles in mainstream OO languages. Is that a fine thing, or would you rather have seen something else? Where do you see it going?
No, so I think it's a fine thing. So I see functional programming as a radical and elegant attack on the entire enterprise of writing programs. It's not just a little delta on conventional ways of writing programs. It's a whole different way of thinking. You have to kind of rewire your brain. I think it's been a joy and the privilege of my life to be allowed to, even paid to, study functional programming pretty much full time for an extended period to see if we could take that one idea of purely functional programming, make it practical. Now, then of course, you know, it would be kind of nice if that would just take over the world. But in a way, my goal is just to take that idea, that radical attack on the enterprise of programming, and see just how far you can take it. And then if that results in ideas from functional programming being taken over into the mainstream, that's all good. That's all good. It's not necessary for me to become the mainstream. It might, I still think it might. I don't think it's all that disappointing. I think compared to 40 years ago when I began, when functional programming was very much an academic ivory tower corner populated mainly by logicians. Now it's actually used in industry a lot. This is a whole different ballgame now. I think the graph is still steadily rising. I don't think we've plateaued anywhere near. So sometimes I say when the limestone of imperative programming has worn away, the granite of functional programming will be revealed underneath. But this is a geological process that takes place over a long time span, and it may have outcomes that are surprising, and I don't presume to predict all of those.
As long as we're forcing you to predict a little bit, Where do you see things going for computing as a whole over the next 10 years or so? Do you have any uh, crystal ball there?
Oh, not much. I mean, the lab that I work in, Microsoft Research at Cambridge, is now strongly focused around machine learning, like so much else of computer science. And that is actually another radical attack on the entire enterprise of, so if you start off with the job description of how do we persuade a computer to do something useful for us? Well, writing programs is one way, but machine learning, it really is another. It's quite a different way of instructing a computer what you want to do. So I'm sure that will, that will go a long way, and it has its own complications and its own risks, and it's a bit of a wild west at the moment. So I would hope, one of my hopes for the next 10 years is that we'll get a bit less wild west about it. It feels like biology in the 18th century to me, in which we're collecting and classifying things, but we don't yet have good predictive models for what will work work well in machine learning. We just try lots out and throw immense amount of computing power at it, hope we find something that works. There's a lot of suck it and see. So that's one hope that I've got, is that will improve. And maybe a bit more of a connection then between, at the moment it's sort of machine learning over here and functional programming and other, well, programming in general over here. Maybe there'll be some kind of coming together. I don't know, but I don't really have, I've always been a kind of look at the next year or two rather than the next 10 years kind of person. I don't prognosticate very much. Oh, will also say, I think quantum computing in 10 years time will still, may still be 10 years away.
All right.
Oh, and maybe self-driving cars will also still be 10 years away. We'll see.
We'll see. All right, let's go a bit more technical. Omer Sinan Aga Khan asks, what are your thoughts on lazy evaluation after almost 30 years of implementing it in a compiler and also using it? Should it be the default?
40. So here 40. I think so for functional programming with values, right, and with strictly controlled side effects or carefully controlled side effects, I think that's the granite, right? For lazy evaluation isn't part of the granite. It's for me, it's a seductive idea that I've always loved and always stuck to. And one way to put it is, if we were designing Haskell again, would it be a lazy language? And I've often speculated and thought, no, maybe we'd make it a call by value language. And then I'd have been sitting here 30 years later saying, maybe we should have made it call by need, right? So, and of course, Haskell has strict features, and strict languages have lazy features. So they're all sort of trying to meet in the middle somehow. And I spent quite a lot of time thinking about intermediate languages that support both strict and lazy evaluation. So at least at the intermediate language level, a compiler wouldn't really have a deeply built-in choice. But I think as far as the source language goes, my instinct is still to stick with laziness by default, but I would be, I've on other days, I think, no, it's just too much of a pain. So it feels like more of a free choice. Whereas I will say for purely functional programming, say functional programming, this is the true path, right? This is the North Star towards which we should go, and be very careful about deviating from that. So it's a different kind of conversation about those two.
What about type inference? So in there's the question from Matt Noonan at CrowdStrike. In the early Haskell days, full type inference was an important language design constraint. And over time, we learned that people would be willing to write some type annotations in exchange for new language features, as long as the annotation burden was not so bad. How has your thinking evolved?
So one thing to say here is that it's not an either-or thing. Every language, no matter how how much you say it just uses type checking, it's really got a form of type inference. Nobody supplies a type for every single sub-expression in their C# program or their Java program or even their C program, right? So type inference is kind of everywhere anyway. The question is just how much. And in particular, one choice point is, when do you have to put a type on a binder? Particularly, a lambda binder or a let bound thing. And I think we've gotten quite good at learning how to infer the types for many binders. And that's really helpful, really helpful. I would be I think it would feel qualitatively different if Haskell forced you to put a type on every binder. And indeed, mainstream object-oriented languages increasingly allow you to leave types off binders. So it's all a spectrum. So I think we're just moving, in Haskell and the ML world, I think moving in the direction of full type inference with no type annotations of any kind, and moving towards adding type annotations selectively when it enables you to be more expressive. And other languages are moving the other direction. So it's a bit like that lazy evaluation versus call by value evaluation. It's not really an either or thing. We're all on the spectrum and we're all just trying to find an optimum. I'm pretty happy actually with the position we've got to in Haskell land. The sort of compromise with bidirectional type inference and delayed constraint solving, which GHC now embodies, seems to work very well in practice. And in fact, there's I've just about figured out how to do implicative polymorphism mixed with type inference. Finally, there's a paper at ICFP about that.
Nice. What about intermediate languages? So Omar again asks, what are your thoughts on optimizing typed intermediate languages in type preserving ways, as you do in the GHC core?
Yeah.
Does it lose optimization opportunities, or do you think the core type system could be improved to make these kind of optimizations easier or better, more possible?
So here, I think this is a sort of big bet that GHC makes, which is to have an intermediate language that is remorselessly statically typed from front to back. So every single intermediate program in GHC's compilation pipeline can be, is fully statically type checked. And that, as Omar's question implies, has costs as well as benefits. But it's incredibly helpful in a number of ways. So one thing is, a practical way is it helps us make sure the compiler is right? So it's awfully easy to write a bug in a compiler. And if the first time you hear about it is when you get a seg fault at runtime that was at some way previous pass that just did something wrong, that's just awful. So it's been incredibly helpful for maintaining sanity in what was quite a compiler that really does a lot of transformations. A second thing is it helps us keep a sort of intellectual grip on the language. At the moment, anything in the source language, the source Haskell, is quite wild and woolly. We got lots and lots of extensions, but they all translate into this single statically typed core language that really does have a formal description. So it's a sort of, again, it's a North Star thing that says, if you can just desugar some source language stuff into this statically typed intermediate language, then you haven't really invented anything new. You've just got syntactic sugar. It may really help from a programming productivity point of view, but it's just syntactic sugar on top of this thing. And so everything, all your existing machinery will work. That's really, really helpful. Now, it does have costs, I think, and those costs are clearly fairly significant. Otherwise, everybody would do it. And I think I actually don't know any other compiler that's used in production daily by thousands of people that has this kind of static type property right from front to back. Tell me if I'm wrong. But as Omar's question says, at the back end of GHC, we do translate into this lower level language, the SDG language, and it's really only typed in terms of representation. That is, an int and a bool have the same type in that intermediate language, but an int and an int hash, an unboxed int, do not have the same type. They have different representations. So as it were, I think there's still a systematic story to tell. You translate from a statically typed language in sort of system F style to one that still has a static type, but in which is coarser, but still guarantees you won't get any seg faults at least. Yeah, so I'm still, I guess the answer to the question is, I still think that's a design decision that I'm absolutely happy about. I think it's one of those, it's again one of those things that it's a great privilege to have been allowed to build a compiler that stuck to that for 30 years, and it still makes sense. So is it the best or only way? Well, it's clearly not the only way to build a compiler. Is it better than the alternatives? I don't really know, of course. I just regard GHC as a sort of existence proof of the costs and the benefits of doing so. But it as an intellectual tool, fantastic. Okay.
There are many, many more questions, and we'll come back to some of the more technical ones in a few minutes. But since there are some people, I'm sure, that that need to drop off for something else in 5 minutes, I want to make sure that we get to a little bit of conversation about education, where you've been spending a lot of your time over the past few years. So there are lots of questions about that from many people, but I'll just choose one from Robert Chatley that says, you've been thinking a lot about teaching computing in schools. What do you think about programming languages for teaching computing in schools? Is that important? Are there features that are critical there?
Yes. Okay, so I don't feel as if I have a well-informed opinion about this, but to have a well-informed opinion about how best to teach programming languages to children, you need to be a sort of educational researcher. So the high order bit of what's happening to computing education in Britain is, let's teach computer science as a foundational discipline to every child from primary school onwards, just as we teach natural science as a foundational discipline to every child from primary school onwards. Not because they're all going to become natural scientists in their professional lives, but because it informs and underpins people's judgments and understandings about the world that surrounds them. So that's really the important thing. And that is the bit that I and CAS, Computing at School, and the reform of the curriculum are focused on remorselessly. The national curriculum in England says nothing about programming languages. It just says what aspects of computer science should be studied. So so then you might say, okay, so now we want to teach computer science. What programming languages would be the best to do it? Well, the sort of de facto consensus is you start with visual programming language like Scratch or Kodu or MakeCode, and then you progress to a sort of language that you write with ASCII, sort of textual language. And Python has turned out to be essentially the winner there in the educational setting for some while. So I think it would be really interesting to study what would happen if you really taught functional programming very, very early. It's more or less as soon as you got, maybe use Snap instead of Scratch, but Snap is based in a functional paradigm, and move fairly quickly to a purely functional approach. One way to think about that is to say, imagine you were teaching programming using Excel. The thing I like about Excel is it's a very weak functional programming language, but it is purely functional, right? And you don't have to apologize for the absence of side effects. They're just not. It wouldn't make sense for it to have them. So if we could only make Excel into a decent programming language with function abstractions, lambdas and nestable data structures, that would make quite an interesting language to use for teaching. So for me, the sort of apotheosis of my professional life would be to teach functional programming to children using Excel, and that would bring educational functional programming and Microsoft Research all together. That would make me very happy. But I would regard that combination as being a hypothesis, an experiment, not something I'm actively saying is the best thing. I don't. Pedagogy is hard. It's complicated. So let's find out, but we need to do it thoughtfully and with educationalists.
Here's along the same lines. Here's a slightly provocative question from Sophia Drosopoulou at Imperial, who observes, if we teach more CS at the primary school level, will we end up teaching less math? And if so, would that be a pity?
No. So, so the first thing to say is, this is a pressing question in many countries that don't have computing already as part of their curriculum. One of the ways in which we were lucky in this country is we already had a school subject called ICT, Information and Communication Technology, so that we could rebalance that in favor of computer science rather than, as it were, try to steal curriculum time from other subjects. So that was really helpful for us. But more to the substance of Sophia's question, for me, computer science is mathematics made incarnate, right? Made flesh, made tangible. If you think about a loop is induction, in execution, right? If you think about how am I sure that the loop does give the right answer, you have to write an inductive proof. So as it were, you can almost think of as computer science as the way that we manifest or animate mathematics. So in my dreams, again, we wouldn't, at least at the early stages, until age about 11 or 12, we might not teach maths and computer science as separate subjects at all. Maybe we just have maths and computer science, and teach it as one seamless whole, with each sort of illuminating and, you know, and suggesting avenues to explore in the other. I think that'll be amazing. I think that's a pretty hard thing to do, because it would require teachers who both have an understanding and appreciation of mathematics and have an understanding and appreciation of computer science. And that's really hard. It's really hard to find teachers who've got that understanding and appreciation of computer science. So adding in the maths would be difficult, right? So, but that would be my sort of long-term aspiration. And there's another whole strand to that, to do with using computers as a tool for mathematics. This is Conrad Wolfram and his friends in computer-based maths, who say it's silly to teach all this procedural thinking mathematics when we can automate a lot of those procedures, as we do with sort of calculators. And that's another rather separate issue, but it plays into this same thing. So yes, I would love to have. I don't want to have computer science and mathematics in conflict or tension. I want them to enhance each other, so that, you know, 1 and 1 make 3, not make 1.8.
Let me quickly interrupt, Simon, to say to everybody that's here, this is the end of the official 20-minute slot that was allocated in the schedule for this. So people may need to go and see other sessions. If so, I hope you enjoyed with hearing a little bit of Simon's views of the world. Anybody who isn't occupied with something right now is very welcome to stay, and we're going to continue talking for 20 or 25 minutes. And then if there's yet more, we'll move to some other venue. Simon, I'd love to continue on the education front. There was a question, I forget who asked it, I'm sorry, just for a little status report on how things are going in the UK with revamping primary education.
Oh, well, the big new thing is that we moved from sort of guerrilla organization, computing at school, to that the Royal Society produced first a report in 2012, which said we need to fix our curriculum. And that was, the government is able to hear the Royal Society when it speaks, and in a way that they're not really able to hear pressure groups. So that led to the change in the national curriculum. 5 years later, they produced a report, 2017, called After the Reboot, which was a State of the Nation report. So just type in After the Reboot Royal Society, and you'll get a snapshot answer to your question, a 100-page report that gives the State of the Nation 2 years ago. So that in turn led to the government making available about £80 million for a teacher professional development program in the UK. So this is really important. If one teacher is gets it about computer science as a foundational subject, they will influence hundreds or thousands of students. The teachers themselves are a very high point of leverage, and so we need to train and support them and give them professional development, and that's what the new National Centre for Computing Education is about. And it's a centrally funded top-down program, which I have the honour to be the non-executive chair of, and that's the big new thing on the block in the UK at the moment. So lots of teachers are doing lots of well-structured, well-organised professional development courses. There's lots of curriculum material being developed. It's all remarkably good, and it's all available for free, under open government license, so you can use it and remix it in other countries. So it's all, anybody can use this stuff. Of course, it's all been knocked sideways by the coronavirus. So now we're all pivoting to doing that online. So everything's a bit at 6s and 7s. But the fact is, there's been a big quantum change in the way that computer science education is treated in Britain by a nationally funded program of professional development for teachers, with materials and courses and everything that can be used by anybody in the world for free. I think that's amazing. I'm really excited about it.
That's great. And do you actually manage to have any time to do research? You seem to.
Oh, well, yeah, I was fixing bugs in GHC today. So yes, I'm involved in, so I still do a lot of Haskell stuff, right? And that's fairly centered around GHC, but it does, and particularly in its type system. So I use GHC as a kind of launch pad for research. So adding in predicative types, or being more systematic about the way that we treat arity, or doing a much more better and more principled job for reporting pattern match coverage checkers. These are not, as it were, big epoch-making things. They're little incremental step forwards, but that's the way we make progress, one book at a time. I'm also involved with my colleagues at Microsoft Research I'm officially a machine learning person now. So I'm involved in a project in which we're trying to use machine learning to learn an optimizer. So after all, optimization is just, you can think of it as a machine learning problem. I present you with a program, feed it to this recognizer, and it spits out a location in the program and a rewrite rule to apply. You apply that rule, and then you feed the new program to the recognizer, and it feeds out a new position and a new rewrite rule to apply. Just keep doing that. What could be so hard? Well, it makes AlphaGo 0 seem very, very easy. There's a very big search space, but that's what research is for. It's a good challenging problem to tackle.
Let's go back to education for a minute.
That's what the amazing thing, like I started. I have nobody, sorry, I have nobody reporting to me, and that means that I do actually have time, fantastically, to be able to think about things like that, which is great. Sorry, go ahead.
No worries. You're in a fortunate position. This is a question again on education, but not for primary kids, but for grown-ups. Mm-hmm. This is from Hanali Tavante, who's a PhD student at McGill. What are your suggestions for making more students and industry practitioners interested in programming languages generally and functional programming specifically? How do we bring people into the tent, or are they coming anyway?
I'm not sure I have anything very constructive or interesting to say about that. I think it's, for me, it's a question of sort of conveying the inspiration, right? So not so much about programming language research, but it's that light in people's eyes when they get the idea that, oh, this weird functional programming thing, you mean you can actually do this for real? And this weird type inference stuff, it works at scale. You can do just such amazing things with types these days, and that is inspiring. I think one thing that's changed a lot is that nowadays you look at the blog posts of people in industry writing about their in production systems, and they're talking about functors and lenses and stuff that you might think only would be in the blog posts of PhD students. It's remarkable. So I'm not sure I've got any very helpful response to how we can do better about conveying the ideas. No, sorry, I'm not being very helpful on that one.
Okay, let's try this. From Mike Hicks at Maryland, who observes that programming is a human endeavor, and yet most programming languages are scientifically evaluated, when we evaluate them at all, via proofs in mathematics or via performance measurements using benchmark suites. How do you feel about this state of affairs, and could we do better?
I think it's the primary weakness of the programming languages community altogether. If you look at POPL and ICFP and PLDI, Mike's absolutely right. We should do a lot more about, because in the end, what matters about a programming language is that it makes programmers more productive. And how can you possibly know if it makes programmers more productive unless you give it to some programmers and see if they're more productive? But it's really hard to do that, and it doesn't match the skill set of most of the people in our community, and so we just don't. In fact, I've recently been involved in a paper about adding sheet-defined functions to Excel, which was, and it contained some stuff about principal types and principal elastic, it's called elastic sheet-defined functions, principal derivations, but it also had a user study. So I was terribly proud because we submitted it to PLDI and ICFP and POPL, and all of them rejected it. So it's now heading for journal publication, I hope. But it's really hard to persuasively address all of those things at once. I mean, clearly, I'm not criticizing the conferences. It's just that to be persuasive, you have to address your community. So I regard it as a shortcoming and quite a serious one, but one that I don't think there's an easy way to address, because it is genuinely hard to know what constitutes a true improvement in programming productivity. And in a way, so we can look at take up from industry is our best proxy, right? And functional programming has had a lot more take up from industry, so that is an encouraging proxy, but it isn't the same as controlled experiments. So yeah, I wish we could do more, and I don't really know how, because it's not just because our setup precludes it. It does. Doesn't make that easy, but also because it is genuinely difficult to do.
Let's go back to Haskell. So this is from Carl Pomskog from KTH in Sweden. And he reminds you that in the 2009 book, Masterminds of Programming, on page 196, you said that, quote, formalism can be a brake on innovation. Have your views on this evolved since then, or are you still opposed to having a normative definition of parts of Haskell in some machine-checked formalism?
Okay, so yes, I'm definitely not opposed to having a normative definition of parts of Haskell in machine check formalism. In fact, as I was saying earlier, GHC's core language, the intermediate language, it's at least it's in OT, thanks to Richard Eisenberg. So we do have a formal description. We don't have any machine checked proofs about it, so far as I know, but it's sort of within scope. Stephanie Wyrick and her colleagues are working on some of that, but it is actually quite hard. But I think my comment in that interview, it was a verbatim interview, incidentally, which they then transcribed, I think. Always be careful what you say in verbatim interviews. So I think what I meant was that if our bar to changing the Haskell source language had been that we must have a fully formal machine-checked definition of the language, I think that's too high a bar to allow the language to evolve. So Haskell as a language is evolving quite rapidly still. The GHC proposal process, which is our sort of RFC mechanism, has 200, 300 proposals in the last couple of years, many of which have been accepted and some of them have been implemented. That would never happen if everything was fully formalized. Now, and if you look at those proposals, I think you'll see that the quality bar is quite low. Quite a lot of those proposals are not well formalized at all, and that's the design point, the design trade-off that in effect the Haskell community has chosen to make. Well, certainly I have, that by having a relatively low bar to entry, let 1,000 flowers bloom and see what gets used, anchored really mainly by having this core intermediate language that is very solid. But there are other design choices. You could make things in a more formalized with a higher bar, and I don't think that's better or worse, it's just different. But I do think that the higher the bar is, the less rapidly you can innovate, and that has benefits because it makes the language more stable, it makes it more reliable in production, but it has costs in that you can't innovate as rapidly, you can't explore the design space as much. And Haskell is right at the bleeding edge of let's innovate rapidly and hope that we don't break anything too badly.
This is related to a question from Abhirup Sarkar at Chalmers, who says Haskell has for a long time been a research laboratory for PLIDs, and it's accumulated a vast wealth of features. What are your thoughts about continually evolving an old language and keeping it, this says keeping it simple. I'm not quite sure I agree with the premise, but let's say keeping it as simple as possible while avoiding being crushed under its own weight.
So I suppose I see Haskell is on a trajectory towards eventually being crushed by its own weight, but that we've managed to spin it out an awfully long time. Right? I remember Simon Marlowe and I 15 years ago saying Haskell is full. Enough, we can't do any more. But we've done a lot more since. So the intermediate language keeps us sane, so that stops us being crushed under its own weight. I think there is a lot of feature interaction. I do spend a lot of time thinking about the sort of interaction between language features. Certainly the steering committee who evaluates proposals spends a lot of time thinking about these unforeseen interactions. So there are real costs, but the core of purely functional programming and static typing, right, supported by actually pretty formally defined static type systems, has proved remarkably robust to all of this stuff. So I would say that much of the complexity that you see is ultimately superficial, and therefore less worrying, if you like. But that in the end, but maybe I should say that I hope that one day somebody will come out with a language that embodies all the best things of Haskell, find some way of simplifying into a simpler core that does all of the good things without the complexity. And if that's possible, then bring it on, right? but until then, I don't know how to do that. And until then, I think we should just keep marching forward.
And I think an example of that sort of thing happening was the transition way back when from Camel to Camel Light, wasn't it? So the Camel compiler had gotten fancier and fancier and heavier over the years, but everybody believed that it was too hard to change and there was too big a code base and so on.
Yeah.
And then all of a sudden, this random PhD student named Xavier came along and built his own little thing. And a year later, everybody was using it.
Oh, I mean, that's another possibility. You could imagine the language staying the same, but having a completely new implementation, right? That the implementation might get older and crufty. And we do spend a lot of time. I spend a great deal of time refactoring GHC's existing implementation. I cannot imagine, I just cannot conceive of how this would be possible in a dynamically typed language. So it's just, it's astonishing how much more productive a statically typed language makes you for that kind of thing. But so 30 years on, GHC's code base is still undergoing radical change and is constantly being refactored. So I think one thing we have paid a lot of attention to is not just allowing craft to grow, but to investing effort into, paying back technical debt, if you like, and refactoring as we go. But there have been several very large increments, like adding type in type was huge, adding kind polymorphism, pervasive kind polymorphism was huge, moving towards having typecasts in types has been very big. So there've been some adding linear types is quite a big systemic change. So there've been some pretty big changes in the intermediate language itself. And those have been, heart-lung transplants. But I think GHC survived them.
Seems to still be going strong. Should we step back a little bit to some a little bit broader questions? Here's one from Dominic Orchard at University of Kent, who says, "You've done lots of fantastic work, Simon. I can only agree. Do you have any tips for being this productive and managing work-life balance?"
Two things. Find good collaborators. So I can't remember when I last wrote a single authored paper. Have I ever? I'm not even sure. So working with good collaborators is a fantastic way to become more productive. And I've had the privilege to work with, I think I've co-authored with 150 plus people. And that's a huge privilege and, productivity boost. So my success, such as it is largely piggybacked on them. So thank you to my co-authors. As far as sort of work-life balance is concerned, for me, I sort of obsess about things. I lie awake at night thinking about type inference. It's scary. So would be a danger that I just become stuck in work. But what has, I think, stopped me doing so is having children, probably. So children force you to pay attention to something else because their needs will not wait. And my biological children are now grown up. They're in their late 20s, and indeed one of them, Michael, is even working in Haskell on GHC himself, poor boy. But I adopted 3 young children 6 years ago, and they are at the moment responsible for keeping my work-life balance because you have to pay attention to them. But and this will be different. Some people are single or don't have children, but then I'm sure all of you will have other big parts of your life that are not computer science that are important to you and that you're going to focus time on. And that's really thing. You need an alternative center of gravity, if you like, to avoid getting sucked completely into the vortex. That's really what I'm trying to say. And for me, it's children. For other people, it will be something completely different. Photography, for example.
Maybe talking about work-work balance. This is a question from Lars van den Hak from Eindhoven, who asks, "What is the thing you love most about your job as a researcher, and what is the thing you dislike the most?"
The thing I like most is undoubtedly the privilege of being allowed to do pretty much what I want every day. That is an amazing, how many people get paid to do whatever they want? That is an incredible job description. And I've been lucky enough to do that for nigh 40 years. So I think it's a huge blessing. What do I dislike about it? Well, research work constantly forces you to confront your own inability to think and fallibility, and so you're sort of always on the edge of what you can do. So you have this constant sense of inadequacy, if you like. That I ought to be able to understand this, I ought to be able to see my way through it, but I'm just sort of stuck or going around in circles, or I'm sure I had this same thought 3 weeks ago, but I can't remember why it was a bad thought, and I'm going around the loop again, all that kind of stuff. So that's, and I don't exactly, I'm sort of, I know that's what life as a researcher is like, but it's, I don't exactly like it, but it is also stimulating, but sometimes you do find a way through that. The other thing I think I maybe dislike a bit is going back to this thing about feeling that our whole field is a bit inward looking, that we're not thinking about programming languages as a way to make people more productive, but that there's a constant danger of us becoming introspective. So I'm always try to think about how can we look outwards and serve people who want to write programs rather than just people who want to prove theorems about programs, that is. So there's a bit of a tension there, I suppose.
A question from Jeremy Gibbons at Oxford, who observes that you and Tony Hoare have both seemingly done okay without PhDs, but do you have any regrets about not having done one, and might you do one day when your life gets a little quieter?
Oh, no, definitely not. No, I regard it as a great stroke of luck that I managed to land in academia without having a PhD. I think I spent, after I left university with the bachelor's degree, I spent 2 years working for a small company before I got a job as a lecturer, a permanent tenured lecturer at UCL in 1984 or thereabouts. But that was because at the time there was a huge shortage. Computer science departments were expanding fast, and there was a huge shortage of computer science faculty. So mainly, if you had a pulse, you could get hired. At least I think that must have been the case. Otherwise, they wouldn't have hired me at the time. So, and once I was sort of in, I then managed to escape the need to get a PhD thereafter. But and why do I say I wouldn't want to do one now? Well, mainly because a PhD thesis is a very large piece of solo work, and I'm intensely collaborative. I like working with other people. And a thesis is also a very big piece of work. Mainly, people do read theses, but they read papers first. So I feel as if papers are a more digestible communication medium. That is, if you're going to devote, let's say, 2 years of your life to doing something, and part of what we do is we generate our ideas and we want to transfer them from our brains into the brains of other people in the hope that they'll enrich their lives. Well, breaking it into smaller pieces is a more effective way of doing that sort of transfer, and therefore it's not a unidirectional thing, and therefore dialogue and conversation, than a single monolithic thesis. In some ways, I think our whole system, asking the very first thing we ask young researchers to do exactly this, is kind of odd. And it's our culture and structure at the moment. But I think if we thought from a blank sheet of paper, if a Martian came and said, how do you train young researchers from the beginning, I'm not sure that's the way you'd think of it from the beginning.
Okay, so I'm taking a look at the time and also at the list of questions that we haven't gotten to. People seem to have a lot of questions for you, Simon. But in a few minutes, we're going to need to switch from this channel to let the next AMA session start getting set up. So I suggest that we create a room in the Clouder space, in the space that's reached from by saying /video in a Slack channel. So we'll create a room there, and Simon can go there, and anybody else who wants to can go there. The room, I think, hasn't been created yet, but will be shortly. We'll announce it on the PLDI Ask Me Anything channel, and we'll have Simon's name in it, so you should be able to find it. So maybe we'll just have 1 or 2 more questions here, and then switch over to there. Mm-hmm. If that sounds good, Simon. Let's see. Okay, this is another one about sort of career strategy from Troels Henriksen from Copenhagen, who says, much of your research has been centered on extending and moving a single language and a specific technology, namely GHC. Would you recommend this path to new researchers to aim for this kind of focus? What are the downsides? What are the upsides of structuring your research life this way?
Oh, yes. So this is a big design choice, if you like, that I don't think I made it explicitly. I didn't, but I made it implicitly. So Haskell and GHC are both a springboard and a ball and chain, right? So a springboard because if you do something in Haskell and you implement it in GHC, that gives you a sort of immediate level of credibility that this must work at some kind of scale. It gives people a way to try it out. And also because there's a very large user base, it also gives a large pool of people who might actually try it out. And sometimes they will also serve as, they will constantly suggest things that you might do. They'll say, if only we could do this in Haskell. So it's really helpful as a springboard and as a laboratory. And indeed, GHC is, it's consciously set up as a laboratory. So we will sometimes do something. Linear types as an example, where I don't know whether the new approach to linear types that we're going to have in GHC shortly is the best or only way, but it's a well worked out way, and GHC is exactly a laboratory to try those sort of things out in. Now, but it's also an impediment, right? It stops me as a researcher being nimble. I'm hugely admiring of people who write papers in a whole variety of areas and seem to constantly, or at least regularly, reinvent themselves. And I can't do that so easily, because it would mean leaving behind this baby that I love and cherish so much. So there are definitely pluses and minuses. So Charles, I don't know. I think there's a I wouldn't say this is. I would certainly not say this is the only way to do it. I think it's probably quite a high risk way, actually, because if you become attached to a particular implementation, well, it might be ones that doesn't catch the wave, that isn't regarded as a thought leader, that not many people use. So then you made all that investment, and what for? I think probably most people should be nimbler, but I think it's quite important that some people stick to one thing, so that cock, say, is what it is, because some group of people has stuck to cock and keeps enhancing it and making it what it is. They didn't just move on to something else, leaving it behind in the dust. So some people should do that. Yeah, do both. What I mean is both are valid. Probably a majority of people should be lighter footed than I have been.
Okay.
It's Ali here. I just wanted to say that
yes,
there's some technical problems with Clara right this moment. So I suggest just keep going here, and we'll let you know when we're good to move.
Okay.
Okay.
That sounds good. Let's see. Oh, here's an interesting one. This is from Artem Pelenitsyn from Northeastern, who says, these days, fast prototyping seems to be a vital feature for language adoption. So thinking of languages like Python and R. Do you think that Haskell can make more steps toward being more flexible and permissive, and maybe including changing its compilation approach from ahead of time to just in time? What are your thoughts in that space?
Yeah, so I think it's I would love to have a just in time compiler for Haskell. I think it's a huge engineering challenge, right? So I'm not sure it's the same as rapid prototyping, right? So maybe we could just be more nimble about compiling doesn't need to take a long time. We've got quite powerful machines, and if you'll just keep recompiling the module that you're working on, might not be so bad. I'm not sure you need a JIT compiler to be to do rapid prototyping. Often people think that this sort of rapid prototyping is also coterminous with dynamically typed languages. I don't think so. So so I think you can. I think if I want to get a program working quickly, right, I want it to be running soon, then I probably want to write in a statically typed language. So these days, GHC with deferred type errors, you can actually compile and run a program that has type errors in it. at least most sorts of type errors. So that has been a real help, actually, because it means that you don't have to get rid of type errors in the bit of the code that you're not working on yet in order to be able to run the bit of the program that you are interested in. And if you actually start to execute the code that contains that type error, well, then it will fall over, and so it should, pointing right back to the type error in the source code. And then there's tons of things to do with engineering, IDEs for Haskell, which are terribly underdeveloped. But fortunately, there's a whole bunch of people have become very interested in building a good IDE for Haskell, and that's really is materially on the way now. So tons of important engineering stuff there. Just-in-time compilation would be a still larger engineering challenge. But I don't see any reason in principle why Haskell shouldn't be just as good for this sort of dynamic, rapid prototyping. Just type some code and run it immediately. Why should that be any worse in Haskell than any other language? Mainly an engineering challenge, quite a big one, perhaps, though.
Relatedly, Claire Zheng from McGill observes that the Haskell community has been developing lots of development tools like GHC IDE and the Haskell IDE engine and the Haskell language server, and wonders whether you use some of those.
How embarrassing. I don't. But that's
Why?
because I'm sort of antediluvian, 20th century person. I use Emacs. Mainly because I, always have, and this space is quite rapidly developing. I think once when I say there's recent work on the Haskell IDEs, a bunch of Haskell IDE projects have now got together and are working together on Haskell IDE project. And at some point, I am going to say, okay, I should just switch and use this. And I will, but so I would say the shortcoming here is in me, not in the tooling. Probably I should have switched some while ago, but it's coming in a way that was not true 10 years ago, just not true ago, and more power to the people who are doing that.
Okay, Benjamin, green light for Clouder.
Excellent. Okay, then Simon, let's close down this session. This has been great fun. I have learned a ton and enjoyed myself a lot. There are still a whole bunch of questions. I hope people will come over to the Clouder and ask them and engage you in further discussion. So let's shut this session down at this point, unless you have any final words of parting.
No, I do not. Thank you very much. It's been a lot of fun.